Hello student, today we will discuss about the pattern of free response question in the segment of mathematical routine. In mathematical routine question, you have to drive the equations and apply the mathematics over it. So in this example, there is a disk of mass m, radius r, and moment of inertia is given to you. And the main important thing is that the slipping rolling without slipping means the contact point is not slipping over the wedge, so that the contact point p, we can say acceleration of the contact point p is 0. So now what they want, firstly they want to draw the forces and their direction. Now second, what they want from us, they want determine an expression for the torque, then determine an expression for the net force, and relationship between these two physical quantities, and drive the expression for the translation acceleration. So in first part A, we need to calculate the translation acceleration and the torque equation. So first we have to level diagram of the force, which we call free body diagram. First thing is that the difference between AP physics, the questions are comprehensive, so you need reading comprehensive skill in you. So there are some forces, it is mentioned that the disk is rolling without slipping. If there is no slipping, that there must be a friction force, because friction force stop slipping. So I can say the direction of the friction force will in this direction, because the tendency of the slipping of the lowest point is towards right, and friction opposes the slipping. Contact force will pass through the center, and gravitation force will act in this direction. So first question, we have to draw the forces and their direction. Now we write the expression for the torque. So we know that the normal force and Fg will not produce any torque, because it is passing through the center mass of the disk. So there is no perpendicular distance. The force cannot produce the torque. So getting my point? Now simply the torque will be produced by the F, and friction force will give the required angular acceleration, so that the lowest point can be remain in rest. I will explain it. So we can write the torque equal to friction force into perpendicular distances radius of the disk. Now torque is also equal to moment of inertia and angular acceleration, I alpha. Alpha is the angular acceleration, and the moment of inertia is given to us in the question itself, that mr square by 2 into alpha. So friction force come out mr alpha upon 2, because we know that it is mentioned in the question, the rolling without slipping, it means there is no slipping of lowest point. So lowest point must be in rest with the wedge, because wedge is also in rest. So for that, no slipping condition, the acceleration of point P must be 0. Okay. But let's say there is a translation acceleration, because the disk is moving along the wedge with some acceleration. We will find that acceleration A, and torque is producing the angular acceleration alpha. So due to angular acceleration, there must be a rotatory acceleration, we can say, in that direction, that is alpha, due to rotational acceleration, and T is a translation acceleration, AT is a translation acceleration in this direction. Okay, so this point to be in rest, then translation acceleration and rolling acceleration must be equal. This is the condition of rolling without slipping, A equal to alpha. Now put the value of alpha over here, so we can find the friction force ma by 2. The first, in first torque equation, we have two unknown, friction force and acceleration of center of disk. So we need one more equation. We will find the equation by the help of Newton's second law. Now we apply the Newton's second law on this disk. So there is a component of gravitation force in this direction, that is mg sine theta. and the friction force in opposite direction, that is F, and net acceleration of translation acceleration is A. A is the translation acceleration. So according to Newton's second law, net force mg sine theta minus friction force can be written as ma, and we have F equal to ma by 2. Now put the value of F. By solving this two equation, we can get the value of acceleration is 2 by 3 g sine theta. So this is the solution of one part of this question. Find the relation of the torque and find the relation of translation acceleration. Next, we have done this part. Okay. Now question is that a ice block of same mass moving on frictionless surface and the disk is rolling without slipping on rough surface. Now they want to uh, give the reason about the time period of the disk and time period of the block when they reach the ground. Which one is greater, equal, and less? So it is very simple question. As we know, the net translation acceleration, the acceleration which covered this distance is 2 by 3 g sine theta, but the translation acceleration of the block on that inclined surface is that g sine theta. So we can easily say that the translation acceleration of ice block is more and translation acceleration of the ring is less. So distance is same, then the disk will have more time to reach the ground than block. So this is a simple solution of type 1 translation in mathematics routine. So, and this is the marking scheme. The question one mathematical routine is total 10 point, and this is a step by step solution. The important point is the writing skill. Descriptive representation of the question is important. So this is the solution of the question. Okay, thank you.